Hey there. Tonight we're stepping into the most electrifying corners of the sky. You can almost feel it, that subtle charge in the air, the faint metallic tang on your tongue, the breeze that seems to pause, as if holding its breath. Somewhere out there beyond the horizon, clouds are swelling like muscles flexing, and the sky is about to perform one of nature's loudest lullabies. You're safe, of course. Tucked-in lights dimmed a soft hum in the background. But what's coming is powerful enough to make even the earth tremble a little. You probably wouldn't survive standing in the middle of it. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, tell me where you're listening from and what time it is for you right now. I always love knowing how far the storm travels. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You feel it first in the stillness. The trees have gone quiet, as if they too know something's brewing. The air wraps around you warmer and heavier than before, pressing softly on your skin. There's a smell, clean, sharp, and somehow metallic, that scientists call ozone. It's one of the first signs that lightning has been at play somewhere nearby. Your senses, tuned by evolution to notice danger, recognize it before your mind does. The world goes silent, waiting for the breath before the storm. Thunderstorms form when warm, moist air near the ground rises into cooler layers above. It's simple physics, really. Warm air is lighter, so it climbs. But as it does, that air cools, and the moisture it carries condenses into clouds. If there's enough instability, enough heat, and enough humidity, those clouds begin to tower like mountains made of vapor. You can't see it happening from below, but inside that cloud, updrafts are tossing water droplets and ice crystals around, like popcorn in a pot. Each collision strips electrons from one particle and adds them to another, separating charges within the cloud. Positive and negative layers form a giant natural battery, stretching across miles. You might not realize it, but the atmosphere above you is constantly humming with electricity. Even on calm days, the Earth maintains an electrical field of about 100 volts per meter, flowing between the ground and the sky. During a storm, that charge can amplify 1,000-fold. It's strange to think that something so chaotic follows patterns. Scientists still argue whether lightning starts from the top down, from the bottom up, or even both at once. A sky-wide handshake between opposites. What's certain is that it begins invisibly, a faint whisper of electrons racing through the air, heating it to temperatures 5 times hotter than the surface of the sun. You don't see that first moment, just the brilliant result. When you watch a storm roll in, you're witnessing a perfectly orchestrated balance between energy and resistance. You might feel a gentle breeze as downdrafts push outward, carrying cool air from above. The hairs on your arms stand up. That's not your imagination. The electric field around you is strong enough to raise each hair like a warning flag. And then the first flash brief, brilliant and oddly comforting. There's something almost theatrical about that pause between lightning and thunder. You count seconds, 1, 2, 3, trying to estimate the distance. Every 5 seconds roughly equals a mile. So if you reach 10 before the sound arrives, the storm is still 2 miles away, just enough for you to enjoy the spectacle without getting drenched. But when the count shortens and the thunder rolls almost immediately after the flash, that's when you know the storm has arrived overhead. In that moment, time slows. The world narrows to the rhythmic flicker of light and the deep pulse of thunder rolling through your chest. It's a primal kind of music, one that has echoed since long before humans walked the earth. Ancient people thought gods were throwing spears, dragons were fighting in the clouds, or celestial drums were sounding warnings. Today we know it's ionized air expanding explosively. But somehow that doesn't make it any less awe-inspiring. There's even beauty in the danger. Lightning can travel up to 25 miles from its parent cloud, sometimes striking out of clear blue sky. Pilots call that a bolt from the blue. More, it's rare but not impossible a reminder that nature doesn't follow our human sense of boundaries. On average, the planet experiences about 40,000 thunderstorms each day. That's 1-800 storms raging somewhere on Earth at any given moment, lighting up the atmosphere like a giant neural network. One of the strangest sensations, though, is what happens when you stand outside right before the rain begins. The world feels suspended. Birds vanish, insects hide, even dogs pause their barking. The reason is acoustic. The dense, humid air muffles high-frequency sounds, leaving you in a kind of quiet vacuum. To your body, that silence feels unnatural, almost sacred. You might take a deep breath, feeling the tension in the air, a pause that seems to stretch forever. And then a gust of wind rushes through the trees, carrying dust and scent, and tiny bits of static, and the spell breaks. There's humor in all of this, too. Humans, being stubbornly curious, invented lightning rods, metal spikes to lure electricity on purpose. Benjamin Franklin risked his life flying a kite in a thunderstorm just to prove that lightning and electricity were the same thing. You can almost imagine the absurdity of it. A man holding a wet string under a charged sky, muttering about science while the universe decides whether to smite him. Yet his boldness gave birth to everything from power grids to weather prediction. Still, for all our knowledge, there's something unknowable about thunderstorms. Even with supercomputers and Doppler radar predicting where lightning will strike, remains one of meteorology's unsolved puzzles. You can estimate, simulate, and measure, but you can't point to a square foot of ground and say right there. The sky still keeps some secrets. As you listen now, you might imagine lying under a roof of clouds, miles thick, each droplet shimmering in faint electric light, each gust whispering of what's to come. Somewhere within that vast gray cathedral, forces you can't see are preparing a spectacle. Light, sound, and water weaving together in nature's grandest stage play. The first rumble echoes again, soft but deep. The breath before the storm has ended. Now the sky begins to move. You tilt your head back and look upward, and there it is. The first great pillar of cloud. It doesn't drift like ordinary fluff. It builds surges and climbs. From the ground, you can't tell how immense it really is, but if you could rise with it, you'd see a mountain forming in the sky. A thunderhead, or cumulonimbus, is one of Earth's most spectacular architectural projects. Vapor molded by invisible hands into towers that can reach nearly 60,000 feet. That's higher than Mount Everest. Somewhere near the top, the air is cold enough to freeze your eyelashes solid in seconds. The base of the storm is a dark, churning underbelly, a plane of shadow that seems to press downward while the upper edges glow white in the sunlight. It's hard to imagine that this colossal formation began as nothing more than a small thermal bubble, a pocket of warm air rising from a sun-baked field or quiet lake. Every towering anvil you've ever seen began with just one lazy spiral of rising air. As that air ascends, water vapor condenses into droplets, releasing heat in the process. what scientists call latent heat of condensation. This released heat acts like rocket fuel, keeping the air parcel warmer and lighter than the surrounding atmosphere, propelling it even higher. You can think of it as an atmospheric feedback loop. Each drop that forms makes the rest climb faster. It's a chain reaction written in vapor and energy. Updrafts inside these clouds can exceed 100 miles per hour, roughly the speed of a fast highway wind tunnel. If you could somehow hover beside it, you'd see curtains of vapor streaming upward, billowing like smoke from an invisible fire. Pilots call these clouds skyscrapers in the sky, and they avoid them with a mix of respect and terror. Radar shows them as jagged red columns, warnings that even the strongest aircraft frame could be shredded by turbulence within. Scientists still argue over how these enormous columns regulate themselves. What stops a thunderstorm from growing forever? Some say it's the weight of the precipitation. Others point to the cooler downdrafts, cutting off the storm's warm air supply. Nature seems to have a built-in safety valve, a way of ending its own fury before it breaks everything. Still, in those minutes before that balance returns, the sky feels alive. You can picture it from far above, where satellites watch the cloud top flattening into a vast anvil shape as the rising air hits the tropopause, that invisible ceiling dividing the troposphere from the stratosphere. There, the current spreads sideways, sculpting delicate ripples that look like brushstrokes across the blue. Lightning flickers inside, faint at first, then bright enough to reveal the cloud's skeletal structure. Veins of white-hot electricity branching through mist. If you were inside that storm, not that you'd want to be, it would be like standing in a giant washing machine filled with ice and wind. Hailstones tumble up and down repeatedly each trip, adding another layer of frozen water until they grow heavy enough to fall. Some are the size of marbles, some the size of golf balls, and a few become baseballs of solid ice. Each one carries the story of its journey in layers like the rings of a tree. The roar you'd hear in there isn't thunder yet. It's the rush of air, water, and ice slamming against each other. Electrical charges separate as particles collide. Small ice crystals stealing electrons from larger ones and drifting upward while the heavier, negatively charged hailstones sink. It's a frozen traffic jam of charge carriers in a vertical highway miles tall. Every thunderstorm is essentially a living engine converting solar heat into motion and electricity. It starts with sunlight warming the ground, and it ends with cold rain cooling it again. An endless loop. The sheer scale is staggering. A mature thunderstorm can release the same amount of energy as several nuclear bombs, yet you can watch it unfold safely from your porch, sipping tea and pretending you understand. Here's a quirky thought. Scientists once tried to control these skyscrapers. In the 1960s, during a program called Project Storm Fury, they flew aircraft into hurricanes and thunderstorms to seed them with silver iodide, hoping to weaken or redirect their growth. It didn't quite work. Nature, as usual, refused to take orders from humans. But it did teach us how delicate storm formation really is. Change one variable, a bit more moisture here, a touch more wind shear there, and the outcome shifts completely. You might chuckle at the thought that clouds, these floating towers of mist, weigh millions of tons. It's absurd, right? Yet that's exactly what scientists estimate. The moisture content of a thunderstorm, its water droplets, hail, and vapor, can weigh as much as 10 aircraft carriers. And still it floats suspended by invisible hands of upward air. There's beauty hidden even in the turbulence. From an airplane window, if you're lucky enough to fly above the storm at dusk, you can see the tops glow gold and pink as the sun sinks below the horizon. Lightning flashes from within, illuminating layers of mist like a lantern held behind frosted glass. For a brief moment, the world below disappears, and you realize the sky itself has terrain. Valleys of vapor, ridges of light. You might think of thunderstorms as purely destructive, but they serve a global purpose. They help regulate Earth's temperature, transporting heat from the surface to higher altitudes. Without them, our planet would bake in its own imbalance. They're the circulatory system of the atmosphere, pumping energy where it's needed, whether we like it or not. And still, for all their grandeur, storms are fragile. A shift in upper-level winds can shear a cloud apart before it matures. A sudden dry layer can choke its updraft. Each one is a balancing act between creation and collapse. The next time you see one rising on the horizon, that majestic white tower stretching into blue, imagine standing at its base, feeling the cool breeze from its downdraft, and realizing you're in the presence of a skyscraper that will vanish within an hour, leaving only the faint scent of rain. You breathe in again, feeling the pressure shift. The mountain above you isn't made of stone. It's made of breath heat and the endless cycle of energy returning to the sky. And though you're tiny beneath it, the connection is real. The same molecules that rise to build that storm will one day fall again as gentle rain on your roof. The air thickens once more. The first flash is near. The skyscraper in the sky has come alive. The storm is alive now. You can hear it breathing low, rumbling exhalations that vibrate through walls and skin. The clouds above are no longer soft or distant. They've thickened into something muscular, a sky flexing under invisible strain. The first flickers of lightning dart within, faint and quick like nerves, firing beneath translucent skin. Then, without warning, one bolt tears through the darkness. It's blinding, instantaneous, and absolute. You blink stunned, and for a heartbeat, the world glows blue-white. Lightning doesn't just illuminate, it creates its own world for a split second. The grass glistens as if lit from within the air, hums, and your body feels like a tuning fork. If thunder is the voice of the storm, lightning is its pulse. A single bolt can reach temperatures of 30,000 Kelvin, 5 times hotter than the surface of the sun. That heat expands the air so rapidly, it produces the sonic boom we know as thunder. You can't separate the two. Every flash carries its own roar, though sometimes the light outruns the sound by miles. Lightning moves at 1/3 the speed of light, fast enough to trace the path of least resistance in microseconds, finding its way down a jagged maze of air molecules until it meets the Earth. The science behind it is electrifying, literally. Inside the storm, the collision of particles creates a vast imbalance of charges. Positive at the top, negative at the base, and the ground beneath you becomes charged in response, like a mirror reflecting electricity. The moment the difference becomes too extreme, nature resets itself with one powerful discharge. That's lightning's job, to balance what's become unbalanced. But not all lightning strikes the ground. In fact, most of it dances invisibly inside the cloud, leaping from one charged pocket to another. Some bursts stretch across hundreds of miles in brilliant horizontal lines, so-called sheet lightning. Others leap skyward, glowing red above the clouds in silent bursts known as sprites. Scientists still argue whether sprites are the product of electromagnetic waves or some more complex atmospheric resonance. They're so brief that for decades, pilots swore they'd seen ghosts of the upper sky. And then there are the real oddities, the blue jets and elves. Blue jets shoot upward from the tops of storms, reaching the edge of space, glowing neon like some celestial light show. Elves, yes, that's their actual name, appear as expanding rings of red light that spread for hundreds of miles in the ionosphere. The universe has a sense of humor naming its high-voltage phenomena after mythical creatures. Even stranger is ball lightning, a phenomenon so rare that many scientists doubted its existence for centuries. Eyewitnesses describe glowing spheres floating silently through the air, sometimes entering homes, hovering for several seconds, before vanishing or exploding with a hiss. The cause, no one truly knows. Some researchers think it's vaporized silicon reacting with oxygen, others blame microwave interference or plasma bubbles. Whatever it is, it's one of nature's eeriest party tricks, a ghostly orb that defies both gravity and explanation. Lightning's unpredictability is part of its beauty. You can stand miles away under clear skies and still watch bolts arc downward from unseen clouds stretching across blue air to strike out of nowhere. Pilots call these anvil crawlers, fingers of electricity that race along the underside of the storm's highest reaches. To anyone watching from the ground, they're nature's handwriting sketching luminous signatures across the sky. It's not all random chaos, though. There's geometry in the madness. Each bolt forms what's called a leader, a faint stepped trail of charged air that carves the path before the main discharge follows. It moves in tiny jumps, pausing, splitting, deciding. You could almost say the storm thinks before it strikes. When the leader nears the ground, positive charges leap upward to meet it from trees' antennas and even people. For a fraction of a second, countless invisible fingers stretch skyward, each hoping to connect. Only one succeeds, completing the circuit, and that's the moment you see the flash. A quirky fact if you happen to be struck and survive. You might carry the Lichtenberg figure, a delicate fern-like scar burned into your skin by the electric flow. It's painful, yes, but hauntingly beautiful, a living lightning tattoo. Ironically, those scars fade with time, like the storm's signature slowly erasing itself from your body. Lightning also creates something far less visible, but equally fascinating: ozone. When air molecules split and recombine under those intense electric fields, they produce O3, giving thunderstorms that crisp, metallic scent you notice before the rain. So when you say, "It smells like a storm," you're actually breathing in the byproduct of lightning chemistry. And here's a quiet thought for the night. Without thunderstorms, Earth might not have evolved life as we know it. Scientists believe that lightning striking the early atmosphere billions of years ago provided the spark that turned simple gases into complex organic molecules. In other words, every flash in the sky is a faint echo of the first heartbeat of life itself. The irony is, despite our deep fascination, lightning still refuses to be tamed. We've tried capturing it, redirecting it, even harnessing its power. But the energy is so instantaneous that it defies storage. A single bolt can release 1 billion joules of energy, enough to power a small town for a day, but only for less than a second. The universe gives, then takes back faster than we can blink. You chuckle softly at the absurdity of it all. We can split atoms and land rovers on Mars, yet we still can't predict where lightning will strike next. The sky keeps its mischief alive. Outside, the storm's rhythm intensifies. Flash, pause, boom. The air vibrates, but instead of fear, you feel something soothing about it, the reassurance that the laws of nature are still doing their nightly rounds. You imagine those electric veins tracing through the atmosphere like capillaries of the planet itself, glowing and alive. You breathe in your room, faintly illuminated by the next flicker outside. The storm doesn't ask permission, it just exists pure and unstoppable. And in that instant, with the sound rumbling softly through your chest, you realize the world is humming and you're a part of its current. The air quivers, and then it happens. The thunder finally speaks. Not the sharp crack you expect from a firework, but a deep, rolling growl that travels for miles, curling around hills, sliding between buildings, and lingering long after the flash is gone. You feel it more than you hear it. It resonates through your chest, vibrating bones and furniture alike. The voice of thunder is the sky's slow exhale, its way of saying, "I'm here and you're small." When lightning strikes, the air around it expands faster than any explosion on Earth. We're talking speeds of thousands of miles per hour. That rapid expansion and contraction creates a pressure wave, essentially a giant acoustic ripple. By the time it reaches you, that ripple has bounced, refracted, and echoed across valleys and clouds, creating that rich, rolling texture that makes thunder sound like it's chasing itself across the sky. Scientists call this process sonic turbulence. You just call it awesome. The sound's pitch depends on how close you are, how humid the air is, and whether mountains or buildings are reflecting it back. Close thunder has a sharp, violent crack. Distant thunder is like an old engine idling somewhere far away. Both, though, carry that primal undertone that wakes up something ancient inside you, the instinct that once told our ancestors to run for cover. There's a certain irony in the fact that thunder so loud and intimidating is harmless. It's just sound. The real danger, the lightning, is silent. The storm has a sense of humor like that, dressing its warnings in noise, while the true risk strikes invisibly and fast. You might think the speed of sound is slow compared to light, and you'd be right about 1,000,000 times slower. That's why you can count the seconds between flash and thunder to estimate distance. 5 seconds means roughly 1 mile away. But the sound itself doesn't travel evenly. Humidity, air temperature, and wind all bend and twist it. Sometimes you'll hear thunder from a bolt 20 miles off. Other times the sky lights up silently, its growl swallowed by upper winds. You listen closely now, realizing that thunder isn't random, it's layered. Each rumble tells you something about the terrain. A long, rolling thunderclap usually means it's echoing across a valley or large, flat plain. A short, sharp crack might be bouncing off the walls of nearby buildings. In that way, thunder is the sound of geography itself, a sonic map painted in air pressure. Scientists still argue whether the human brain evolved to enjoy that sound or simply tolerate it. There's evidence that rhythmic, low-frequency noises like thunder or waves can trigger relaxation responses in the body. Your brain interprets them as natural, continuous event signals of safety once the initial danger has passed. So maybe that's why you can fall asleep during a storm, lulled by the same forces that once terrified your ancestors in open fields. Evolution has a funny sense of comfort. But thunder also carries secrets about the storm's anatomy. When researchers record its patterns with specialized microphones, they can actually reconstruct the shape of the lightning bolt that caused it. Every twist and branch leaves a sonic fingerprint. Some scientists joke that if you could see thunder, It would look like a glowing 3D model of the storm's veins. Others seriously study those patterns to understand how energy disperses through the atmosphere. And then there's the human response. Cultures across the world have given thunder its own personality. The Norse had Thor hammering at the heavens. The Greeks blamed Zeus, flinging bolts in anger. Indigenous tribes in North America spoke of the thunderbird, whose wings created storms as it flew. Even now, when we know what causes it, thunder still feels personal-like. The planet clearing its throat to remind us who's boss. A quirky fact for your sleepy mind, there's a rare weather event called Thundersnow. It's exactly what it sounds like, a thunderstorm during snowfall. Instead of rain, snowflakes fall gently through the flashes, their brightness diffused in eerie silence. Because snow muffles sound, the thunder becomes muted, distant, almost ghostly. If regular thunder is a roar, thunder snow is a sigh. Meteorologists still debate why it happens so rarely. But when it does, it turns the world into a glowing white symphony lightning reflecting off flakes instead of raindrops. If you've ever been caught in a storm, you know that thunder comes in moods. Sometimes it's impatient and fast-striking every few seconds, like the sky tapping its foot. Other times it's lazy and drawn out, rolling for minutes at a time. That rhythm isn't random, it's tied to how frequently lightning strikes. A busy storm is a loud one. A dying storm grows quiet with longer pauses between rumbles. The sky literally slows down as it runs out of charge. Funny enough, animals sense that slowing before we do. Birds emerge cautiously. Frogs croak again. Even your cat may wander back to the window once the low growls stretch further apart. It's nature's way of whispering we're almost done. If you listen closely between the thunderclaps, there's a special silence that follows, a kind of stillness that's different from the one before the storm. Before silence was tension. After its release, the air smells sweeter, charged with ozone and the faint scent of wet soil. That smell has a name: petrichor. It comes from oils released by plants during dry spells, mixed with compounds produced by soil bacteria, finally carried into the air by raindrops. It's the Earth's version of exhaling after holding its breath too long. And as the thunder drifts further away, you find yourself relaxing too. Maybe that's the secret reason thunder comforts you. It's a rhythm, a reminder that chaos has a pattern and noise can mean safety. There's something oddly human about how we've learned to measure our distance from danger by counting. Lightning, 1, 2, 3. Thunder, safe. You smile softly in the dark, realizing that you're participating in a ritual older than civilization. The next rumble is softer now, but deeper, as though the storm is settling into its own sleep cycle. The rolling voice fades into a gentle murmur, and you feel the air shift again. The temperature drops. The first cool mist brushes your skin. You know what comes next, the music of rain. You hear it before you feel it, the soft patter, uneven and shy, like fingertips testing a drum. Then another and another, until the sound becomes steady, confident, rhythmic. Rain has arrived. The symphony of a thunderstorm is complete. It's strange how something as simple as water falling from the sky can make the world sound so alive. Each raindrop hits with its own pitch, tiny high notes on leaves, deeper tones on rooftops, soft thuds on earth. Together, they create an orchestra that no human composer could replicate. Close your eyes and listen. It's chaos, but it's harmonious chaos. A single thunderstorm releases billions of raindrops every minute. Each one forms the same way. A speck of dust or pollen in the air becomes the nucleus gathering microscopic moisture until it's heavy enough to fall. Scientists call this coalescence. It's not random. The droplets bump into each other, merge and grow as they descend. It's gravity and chemistry dancing together. You can almost imagine them, tiny invisible travelers joining forces mid-air, racing toward the ground. When they hit, they shatter into even smaller drops, sending a faint mist back upward. That's why when you stand in light rain, it feels like the air itself is sparkling. Rain isn't just sound, it's scent, texture, and memory. That earthy perfume rising from the ground, petrichor mixes with ozone and dust wrapping around you like nostalgia. Scientists discovered that when raindrops hit dry soil, they trap air and create microscopic bubbles that burst, releasing those scents into the wind. It's why the first minutes of rainfall smell so rich. It's the Earth's welcome back after the dry silence. There's humor in how humans react to rain. Some run from it as if the sky's about to melt them, while others stand barefoot on their porches just to feel the cool splatter. You might recall being a kid tilting your head back, mouth open, trying to drink the sky. You weren't alone. Thousands of other kids around the world were probably doing the same thing, all connected by the same moment of reckless wonder. And rain isn't uniform. There are fat tropical drops that fall with weight and confidence, and tiny misty ones that float like whispers. Some storms bring sheets of rain so dense they blur the world into watercolor. Others deliver gentle melodic patterns that lull you into sleep. Scientists still argue about what exactly determines the rhythm of rainfall. Temperature, droplet size, and even wind direction all play roles, but no two storms sound identical. The randomness is part of the charm. You could record rain anywhere in the world, play it back years later, and instantly be transported, not just to a place, but to a feeling. Rain also carries electricity, faint but measurable. Each drop as it falls collects charge from the surrounding air. During a thunderstorm, those charges help neutralize the imbalance created by lightning above. It's nature's cleanup crew mopping up stray electrons after the chaos. A quirky fact of the sound of rain has been studied by acoustic engineers who discovered that our brains interpret its randomness as predictably soothing. Because no two drops fall at the same interval, your mind can't anticipate the next sound, forcing it to relax instead of overthinking. That's why rain recordings are so popular for sleep. They trick the brain into calm surrender. If you've ever stood outside during a heavy downpour, you've probably noticed how quickly the air cools. That's evaporation at work, and the rain pulls heat out of the atmosphere as it transforms from liquid to vapor. It's nature's air conditioning system, and it's surprisingly efficient. A large thunderstorm can cool an entire region by several degrees within hours. Inside the cloud, meanwhile, raindrops are constantly colliding, trading charge, and feeding the lightning's appetite. Each impact releases static, helping to maintain the storm's electric balance. You could say the raindrops aren't just falling, they're conducting business. When the wind picks up, the rain shifts direction, slanting like gray silk threads drawn by invisible hands. Streetlights shimmer behind it, every droplet a brief lens bending light in tiny rainbows. Some bounce off puddles, sending ripples outward that overlap and cancel each other like miniature arguments between drops about who gets to sparkle. There's a moment just before the heaviest rain when you hear the rhythm deepen. The lighter taps fade, replaced by steady drumming rain meeting earth at full strength. It's hypnotic primal. Even inside your room, the sound seeps through walls and windows, filling the space with gentle percussion. And yet, no matter how chaotic it gets, there's always a lull. The rain slows almost as if it's catching its breath. You can hear the world underneath again, frogs, distant cars, maybe your own heartbeat syncing with the storm's tempo. Scientists call that break between bursts a microcycle. Poets just call it peace. In that peace, your mind drifts. You think about how every drop of rain that's ever fallen on Earth is ancient. The same water that once filled oceans where dinosaurs drank now trickles down your window. The planet's ultimate recycler. Nothing is truly new. It's just visiting again in another form. And then another wave begins. The storm hasn't finished yet. The symphony continues. Wayne joins back in thunder, mumbles softly, and lightning sketches in the distance. But this time it feels gentler, familiar. The tension of the early storm is gone. What remains is rhythm, water, air, sound, light, all moving in perfect unison. You take a slow breath and let it go. Outside, the storm is drumming on rooftops, whispering through leaves, and washing away the day's heat. It's not chaos anymore. It's a lullaby written by the sky. The rain thickens for a moment, then the light shifts. Through the gray curtain, everything takes on an uncanny glow. Soft greenish, like the world has slipped under tinted glass. The street lights, the leaves, even your hands look different. There's something unsettling and beautiful about that color. It's the color of the air holding its breath. When the sky turns green, most people sense it before they understand it. Animals grow restless. Birds vanish mid-flight. The dogs tuck their tails. Somewhere deep in your brain, a signal flickers, a primitive alarm telling you that nature's mood just changed. You can't see the danger yet, but it's coming. Scientists have spent decades trying to decode that eerie tint. It's not magic, though it feels like it. It's physics light, scattering through thick clouds, heavy with water and ice. Normally, sunlight scatters into the blue hues of the sky. But when massive storm clouds absorb and filter red and yellow wavelengths, what remains is green. You're literally seeing sunlight bent and warped through billions of suspended droplets. That's why you usually notice the phenomenon before severe weather, hailstorms, tornadoes, even supercells. The air is so dense with particles that it becomes a prism painting the world in the color of suspense. Meteorologists still argue whether green skies directly predict tornadoes or just accompany the same atmospheric chaos that spawns them. It's one of those debates that science hasn't quite pinned down. You glance outside again. The light is unreal, half storm, half dream. It's the kind of glow that cinematographers try to replicate in disaster films, but never quite capture. In real life, it's subtler, softer, more personal. It doesn't shout apocalypse, it whispers, "Pay attention." The clouds churn darker, but the green hue lingers like a strange halo around everything. If you've ever seen it before, you never forget. Pilots describe it as flying through liquid jade. Storm chasers call it the witch light. And in folklore across the Midwest, people once said it was the sky holding its breath before the devil took a stroll. You smile at that thought. Humans have always needed stories to make sense of the storm. Then there's the hail. That green glow often signals the presence of it. Thousands of ice stones forming high above, bouncing through the storm's violent updrafts. They grow layer by layer, each lap through the freezing air, adding a translucent shell. When the air can no longer hold them, they fall tiny cold messengers from 10 miles up. The first few clicks on your window are delicate, almost polite. Then the drumming intensifies, like pebbles thrown from the heavens. It's hypnotic in its own way, though you can imagine how terrifying it would be under an open sky. Some hailstones strike with the force of a fastball pitch. The largest ever recorded weighed nearly a kilogram, about the size of a grapefruit. You can picture them forming, rising and falling like dancers in a vertical ballet. Updrafts lift them, gravity pulls them back, and each cycle paints another icy layer until gravity finally wins. Scientists have dissected hailstones to study their concentric rings, revealing how many times each one traveled up and down the storm before falling. The average stone's life is about 15 minutes, short, turbulent, and perfectly sculpted by chaos. Still, even with all our instruments, no one fully understands why some storms glow green and others don't. It depends on sunlight angles, droplet size, the altitude of the sun, and the density of water in the atmosphere. 1,000 variables intertwine like a natural algorithm too complex to reproduce. Sometimes it happens during sunset, when red light mixes with blue shadow and creates that surreal turquoise filter. Other times it emerges at midday, when light and ice harmonize into a ghostly emerald. You chuckle softly at the thought that while humans chase explanations, nature just is. It doesn't color correct itself for our comfort. It paints the sky however it pleases. And yet that greenish hue isn't only a warning, it's a transformation. The world under it feels different. The greens of grass and leaves seem amplified, almost luminous. You can feel the ions building in the air, that prickling energy just before another strike. The wind shifts direction. It's cooler now, sharper. Somewhere distant, thunder murmurs like an afterthought. If you step outside, the temperature drop hits immediately. The smell changes to less earthy, more electric. The storm is recharging, recalibrating. In the distance, lightning flickers inside the clouds, illuminating their bellies like lanterns. You can't see the bolts themselves, but you see their reflections bouncing around the sky's inner walls. It's hard not to marvel at how alive the atmosphere seems. What you're witnessing is a living chemistry experiment the size of a continent. Particles collide, heat flows, energy transfers, and the sky's color palette shifts as each layer of air changes composition. The green light is your window into that experiment, a visible echo of unseen reactions. There's a curious peace in standing beneath such power. You'd think fear would dominate, but it's all instead a sense of being part of something immense, beautiful, and utterly indifferent to you. You're reminded that the same molecules glowing above also fill your lungs. The storm isn't a visitor, it's family. You take another slow breath, tasting the charged air. The green fades, replaced by deep gray as twilight folds in. The storm is moving again, reshaping itself. Somewhere cold air from aloft meets warm air from the ground, twisting gently into a spiral. The birth of rotation. You might not see it, but the storm is preparing for its next act. The air hums, the world holds still, and once again the sky exhales, ready for what comes next. You don't see it, but you can feel it. The air itself has begun to move in circles. The grass bends one way, then another, as if confused about which direction the wind wants to go. The clouds overhead are no longer drifting lazily. They're churning, swelling, feeding. You're watching the invisible tug-of-war that gives a thunderstorm its heartbeat. Every storm lives and dies by this balance. Warm air surges upward in updrafts, columns of heat rising from the ground like ghostly elevators. Cooler air sinks in, downdrafts tumbling downward under the weight of rain and hail. Where they meet, chaos begins. You can't see these invisible rivers, but you can sense them in the way leaves spiral midair or how the rain suddenly changes direction. Inside the storm, the dance is fierce. Updrafts lift droplets higher into colder regions, freezing them into hail or ice crystals. At the same time, downdrafts push them downward with incredible force. It's a constant exchange of energy. Makes one side feeding, the other draining. The storm grows only as long as the updraft remains stronger than the downdraft. Once they balance, the storm collapses like a candle flame, smothered by its own smoke. Meteorologists call this equilibrium storm maturity, the stage when everything peaks. The cloud is at full height, lightning flashes every few seconds, and rain pours down in thick, slanted sheets. The whole system becomes self-sustaining for a time, feeding off its own movement. You could think of it as a breathing organism, inhaling through updrafts, exhaling through rain. You might laugh at how poetic that sounds, but the comparison isn't far off. In a sense, every thunderstorm is alive, temporary, hungry, and self-regulating. And like all living things, it eventually runs out of energy. Scientists still argue about the precise triggers of a storm's death. Some say cold downdrafts cut off the warm air supply. Others blame a loss of upper-level wind support. Whatever the cause, the moment comes when the sky sighs, the lightning slows, and the rain begins to taper. But right now, the storm is far from finished. You hear it in the rising pitch of the wind. It whistles through window cracks and tree branches, an orchestra warming up for another round. The gusts rush downward from the cloud's core, spreading out at ground level like a fan. That's the gust front, a mini cold front formed by descending air. When it collides with warm surface air, the confrontation sparks new updrafts, birthing new clouds even as the parent storm begins to fade. The process can repeat endlessly, storm cells regenerating like hydra heads. A quirky tidbit in large complexes of storms, these cycles can line up into massive chains called squall lines that stretch for hundreds of miles. Imagine a wall of cloud rolling across states, lightning flashing every few seconds, each section fueling the next like dominoes of energy. Pilots flying near them report turbulence so intense it feels like driving over potholes in the sky. Meanwhile, inside each cell, the vertical winds are astounding. Updrafts can reach 150 miles per hour, fast enough to hurl water droplets upward faster than gravity can pull them down. Downdrafts, cooled by evaporation, slam toward the surface at nearly the same speed, flattening trees and bending power lines. Yet if you step outside in the middle of it all, you'd feel as a swirl of wind and rain, not realizing you're standing between two invisible rivers of air battling miles above. Sometimes those opposing flows twist. Wind shear, when wind direction or speed changes with altitude, can tilt a thunderstorm into rotation. That's how supercells form storms, so powerful they create their own internal weather. Within them, updrafts spin like slow-motion tornadoes, forming mesocyclones that can persist for hours. From the ground, you'd see it as a dark, rotating wall cloud, and the sky itself curling like a giant's fist. Scientists still debate the exact mechanism that turns a rotating updraft into a full-blown tornado. The basic idea is simple. A horizontal tube of spinning air gets tilted upright by the updraft, concentrating energy into a narrow column. But the truth is, even with Doppler radar and high-speed cameras, we don't fully understand why some rotating storms spawn tornadoes, while others don't. The atmosphere keeps a few secrets tucked in its sleeves. For now, the air around you feels charged, restless. The rain has eased, but the wind carries fine mist sideways. You can feel sudden bursts, warm then cold, as the gust front shifts. It's like standing between two breaths, the exhale of the storm meeting the inhale of new clouds forming. You might notice flashes high above silent but persistent in cloud lightning, the storm's private conversation continuing far beyond your reach. You chuckle softly, realizing how absurdly busy the atmosphere is at this moment. 1 billion tons of air moving vertically, billions of droplets freezing and melting in endless cycles. Yet it all looks from the ground like a single dark shape sliding across the horizon. Perspective is funny that way. Even the sounds shift as updrafts and downdrafts collide. The low hum of the wind becomes irregular, sometimes roaring in bursts, then fading. You might hear distant rumbles, echoing like footsteps, each one a thunderclap, bouncing through layers of unstable air. Between them, you can catch quieter noises, leaves scraping pavement branches, creaking rain gutters clattering. The soundtrack of a planet exhaling. You take another slow breath. The green glow has faded entirely now, replaced by deep steel gray. The lightning is less frequent, but brighter, sharper, almost surgical. The storm is reorganizing its old cells, dying while new ones rise from their ashes. Nature doesn't waste energy, it recycles it. The temperature dips again. The air smells faintly metallic, the ozone renewing. Somewhere above, the balance is shifting. Updrafts growing weaker, downdrafts spreading wider. The storm is beginning to wind down, but its rhythm still lingers in your bones. You close your eyes, hearing the wind fade, knowing that for every storm ending here, another is beginning somewhere else on the planet. The dance never stops. The sky just changes partners. The flashes return, but they're different now. Not the jagged branching streaks that stab the ground, but strange vertical pillars that shoot upward into the dark. For a second you think your eyes are playing tricks on you. But no, the lightning really is going the wrong way. It turns out lightning has moods. What you're seeing are sprites, those elusive crimson flickers that dance above thunderclouds, high in the stratosphere where airplanes seldom go. They last barely a fraction of a second. So brief that for centuries pilots' reports of upward lightning were dismissed as fantasy. It wasn't until 1989 that scientists finally captured them on film. Sprites are the upper atmosphere's secret fireworks, painting the sky red with tendrils that reach up to 50 miles high. And sprites aren't alone. Their blue cousins, blue jets, burst from the top of clouds in narrow cones, shooting toward the edge of space. There are elves, too, huge glowing disks that expand across the ionosphere faster than you can blink, named by scientists who clearly enjoyed whimsy more than formality. These are lightning's distant relatives' expressions of the same electrical drama, only in thinner air and stranger light. You lie still, imagining them unfolding silently above the storm like bioluminescent jellyfish drifting in the upper sky. They're invisible to most eyes, hidden by the clouds themselves. Yet up there, hundreds are firing every night, unnoticed by the world below. Scientists still argue about the exact mechanisms that create them. Some say they're triggered by the electromagnetic pulse from a powerful lightning bolt below. Others suggest the electric field stretches so far upward that it briefly excites the molecules in the upper atmosphere, causing them to glow red and blue. It's science at its most mysterious verified phenomena that still don't fit neatly into our equations. If regular lightning is a shout, sprites are whispers. Quite evidence that storms don't stop where the clouds end. They reach higher, brushing the edge of space. And then there's ball lightning, nature's strangest party trick. People across history have sworn they've seen glowing orbs hovering indoors during storms, floating through open windows, rolling across floors, even passing harmlessly through walls before vanishing with a pop. For centuries, scientists dismissed these stories as myths, the hallucinations of frightened minds. But modern research and even a few accidental recordings suggests ball lightning might be real after all. One experiment in China accidentally captured a small sphere of plasma floating above the ground after a lightning strike, glowing for several seconds before disappearing. Others have created similar effects by vaporizing certain metals under high voltage. Still, no one can fully reproduce it on demand. Whatever ball lightning is, it remains one of nature's unsolved riddles, an ephemeral ghost in the electrical storm. You grin at the idea that the universe still likes to keep a few secrets. We've mapped galaxies and split atoms, but sometimes all it takes to humble us is a glowing ball floating through a barn. Lightning also has personalities beyond its strange cousins. There's staccato lightning, those single bright flashes that strike once and vanish, so fast they look like the sky hiccuped. There's forked lightning, the kind you doodled as a kid, branching wildly in all directions. There's ribbon lightning, which happens when wind blows the bolt sideways during successive discharges, creating the illusion of multiple ribbons hanging in the air. Even lightning, it seems, has a flair for style. Each flash tells a story about the storm's structure. Long crawling bolts often signal strong horizontal winds aloft. Short vertical strikes reveal compact cells. Scientists use lightning mapping arrays networks of antennas to track these patterns in real time. From above, they see storms, not as flat shapes, but as living, breathing webs of electricity. It's stunning and humbling to realize that each second 100 lightning bolts strike somewhere on Earth. That's nearly 9 million per day. If you could see them all at once from space, the planet would glitter like a pulsing heartbeat, flashes connecting continents in silent synchrony. But lightning isn't just spectacle. It shapes the planet in subtle ways. Each bolt briefly heats the air so intensely that it fuses nitrogen and oxygen-producing nitrates that later fall to the ground with rain. Those nitrates nourish soil-feeding plants and ecosystems. In a strange twist, the violence of lightning literally fertilizes life. The same spark that once terrified our ancestors sustains the green world around us. There's humor in that contradiction. Something that can melt sand into glass, yes, that's real too, also feeds the grass you walk on. Those glassy remnants called fulgurites form when lightning hits sandy soil, fusing grains into hollow tubes. They're delicate and twisted like frozen lightning fingers buried in the ground. You can hold one and realize you're touching the physical imprint of an instant that lasted less than 1,000th of a second. If the storm outside has eased now, it's only temporary. The lightning continues somewhere beyond your horizon. You can almost feel it Even with your eyes closed and the flicker through your eyelids, the faint static prickle on your forearm hairs. The world feels connected by those invisible threads. It's like some vast electric web humming above us. You take another slow breath and exhale. Somewhere out there, a single bolt arcs across the sky, its light bouncing between clouds, illuminating layers of atmosphere you'll never see. For that brief instant, earth and sky are joined by a glowing vein of energy, a reminder that we live inside a circuit larger than imagination. And as the storm continues its electric conversation overhead, you realize you're part of it too. The same atoms that once danced in those flashes now flow through your blood. You are quite literally built from old storms. Sometimes the sky seems to be on fire. It glows orange and gray, and you catch the faint scent of ash. The lightning flashes not from water clouds, but from smoke and dust. This is no ordinary storm. It's a pyrocumulonimbus, a thunderstorm born not from oceans or heat waves, but from fire itself. When wildfires rage with enough intensity, the heat rising from them becomes so fierce that it behaves just like the warm updrafts of a thunderstorm. The air above the flames rushes upward, carrying soot and vapor until it cools, condenses, and forms a towering anvil-shaped cloud. Inside, all the same physics unfolds. Collisions charge separation lightning. Except this time, the cloud was born from destruction. You might imagine it as Earth's way of returning fire to the sky, closing the loop. The flames that consume forests below generate their own weather above, birthing storms that hurl lightning back to the ground, sometimes sparking new fires miles away. It's a self-perpetuating cycle. Nature feeding its own chaos. Volcanoes do it too. When they erupt, the ash plume can stretch tens of miles high. The friction between volcanic particles builds static charge, producing volcanic lightning. Cameras have captured it. Forks of white and blue electricity flashing inside black columns of ash. It's both terrifying and majestic, like the Earth itself is roaring with anger. In 2022, during the eruption of Tonga's Hunga Tonga Hunga Ha'apai volcano, satellites recorded nearly 200,000 lightning flashes in just 11 hours. That's more than most thunderstorms produce in a month. Scientists are still trying to understand exactly how so much energy can be concentrated in such a short time. Was it the ash, the superheated water vapor, the violent vertical motion? Maybe all of it. Nature doesn't always give clear answers. Sometimes it just performs and leaves us guessing. If you've ever seen footage of volcanic lightning, it's unforgettable. Bolts dance around the plume like glowing snakes tracing outlines of chaos. Inside that darkness, static charges build until the air simply gives up trying to hold them back. The result is beauty born from destruction, the universe's way of showing that even ruin can glow. And then there's dry lightning, storms that generate electricity but no rain. They occur when the air below the clouds is too hot and dry for raindrops to survive the fall. The droplets evaporate mid-descent, leaving only the lightning to reach the ground. Firefighters dread it. A single strike can ignite forests in seconds. In a way, these storms are incomplete, half-made, half-born, all danger. It's humbling to realize how interconnected all this is. Fire, water, air, and electricity, four elements tangled in constant exchange. Every thunderstorm is a negotiation between them. Sometimes the balance holds peacefully, sometimes it erupts. A quirky fact: scientists once discovered that these fiery storms can inject smoke and aerosols all the way into the stratosphere, where they linger for months. They even give rise to miniature versions of ozone holes, just like volcanic eruptions do. So while a pyrocumulonimbus may last only hours, its fingerprints can circle the globe. And while fireborne lightning seems violent, it also serves a purpose. In ecosystems like savannas, certain plants rely on periodic burning to regenerate. Seeds of some species won't even sprout until exposed to the heat of a blaze. In an odd twist, destruction clears the way for rebirth. You could say the forest and the storm share the same philosophy break to begin again. Still, there's something eerie about how quiet these firestorms can look from afar. The sky glows peach and amber, and lightning flickers inside without a sound you can hear. It feels almost divine, too enormous to be real, too calm to be safe. You imagine standing miles away, watching as the plume curls upward into twilight. Each flash illuminates the smoke like a heartbeat. Somewhere deep inside that chaos, particles are clashing, air is spinning, and the planet is sculpting weather from flame. Scientists still debate whether these storms count as true thunderstorms. After all, their moisture comes not from oceans, but from combustion. Yet the physics remains identical. The fire provides the updraft, the condensation releases heat, the charge is separate, and nature writes another electric signature across the sky. It's funny, in a darkly poetic way, the same process that gives life to gentle summer rain can also rise from destruction. You can't separate the two sides, the nourishing and the violent, because the planet needs both. Every lush forest that drinks the rain exists because somewhere in the past something burned. The lightning above flickers again, softer now. The firestorms glow dimming. The rain returns, falling through the fading smoke, hissing as it cools what's left of the flames. The balance restores itself, not peaceful but stable enough to last until the next spark. You take a slow breath and realize the pattern you've been following since the first flash tonight. Energy balance, collapse, renewal. Every storm tells the same story, no matter how it begins. Whether it rises from ocean heat or volcanic ash, the rhythm remains unchanged. Above you, the thunder rolls again, quieter now, more distant. The sky is healing itself. The storm has traveled on, but something remains. An invisible hum connecting every flash and drop across the planet. You might think of each thunderstorm as an isolated event, something local that comes and goes. But the truth is stranger. Every lightning bolt on Earth is part of a single continuous circuit. Scientists call it the global electric circuit. A vast planetary heartbeat pulsing silently between the ground and the ionosphere. High above you, about 50 miles up, a thin layer of charged particles wraps around the planet like a glowing veil. Between that layer and the surface, a slow electrical current always flows. It's steady, measurable, and surprisingly peaceful. About 2,000 amperes circulating around the world at any given time. You can't feel it, but it's there, constantly recharged by thunderstorms. Each storm acts like a generator, pumping electric energy upward through lightning discharges. Somewhere right now, hundreds of storms are firing simultaneously, keeping that global circuit alive. Without them, the planet's electrical balance would fade within minutes. You imagine Earth as one colossal battery, its negative pole on the ground, and its positive terminal floating in the upper atmosphere. Every lightning bolt is a spark of maintenance, resetting the charge. The current flows invisibly through the air, into the soil, through oceans, and back again. Even on the calmest, clearest day, the air carries about 100 volts per meter. It's why your hair sometimes lifts near static, why you occasionally sense tension in stillness before a storm. The world is literally wired. scientists still debate how stable that global circuit really is. Does climate change affect it? Do solar flares disrupt it? Some argue that shifts in the ionosphere's density, caused by cosmic rays or solar storms, might alter the Earth's electrical rhythm. Others insist the system is self-correcting resilient, as long as lightning continues to strike somewhere. For now, it hums on quietly regulating the planet's charge like a natural defibrillator. There's something comforting about that thought. That even chaos has routine, that the sky's fury sustains the calm we take for granted. And then you remember that we're not just observers of this global current. We're participants. Your body right now carries tiny electric fields. Your heart beats through electrical impulses, your nerves fire with minuscule charges. On some level, you and the storm are running on the same physics. The difference is only scale. You're a micro-storm wrapped in skin, the sky's logic in miniature. Here's a fun fact to drift on. Researchers once calculated that lightning strikes produce a global resonance that literally makes the Earth ring at a very low frequency, a tone called the Schumann resonance. It vibrates around 8 Hertz, far below the range of human hearing, but sensitive instruments can detect it. It's like the planet's background music, a deep hum powered by all its thunderstorms. Some scientists even think animals can sense it guiding migration or sleep patterns. When astronauts orbit Earth, they've described seeing storms from above as flashing constellations. From that vantage point, the entire planet looks alive. Thousands of pulses every minute brightening the night side like a living neuron network. If Earth were a brain, lightning would be its synapses. You smile at the idea. The thought of storms communicating across oceans, connected by electromagnetic whispers, feels oddly peaceful. Each flash you've watched tonight, each rumble that followed, is part of that global dialogue, the planet talking to itself. But the global circuit isn't just abstract science, it's something you can feel. After a storm passes, step outside and notice how the air seems lighter, easier to breathe. That's not just imagination. Thunderstorms generate negative ions which bond with dust and pollutants, cleansing the air. Those same ions can even affect your mood-boosting serotonin levels. So when you inhale that post-storm freshness, your brain literally rewards you for surviving the chaos. You might even say thunderstorms are the world's natural therapists. They rage, release, reset, and leave calm behind. And like any good therapist, the Earth doesn't explain everything. Scientists still can't agree why certain places experience more lightning than others. Central Africa, for instance, gets struck more than anywhere else on Earth. The Congo Basin, fueled by humidity and heat, lights up like a Christmas tree every night. Meanwhile, regions near the poles almost never see lightning at all. It's a reminder that the planet's weather, like its people, is wildly uneven. Yet, no matter where you are, whether watching a tropical storm or a dry plains squall, you're part of the same system. The same invisible current runs through you, the same hum in the atmosphere connects you to someone half a world away. You close your eyes, feeling that connection, faint, electric, alive. The thunder you heard earlier is already gone, its energy dispersed into the planet's great circuit, circulating somewhere far beyond your horizon. Maybe it's already powering another flash over Africa or a tiny spark above the Pacific. Everything moves in cycles: charge and discharge, silence and sound, fear and fascination. The planet breathes in electricity and exhales calm. You take a deep breath, steady and quiet, as if syncing yourself to that rhythm. For a moment, you can almost feel the hum of the earth beneath your skin. That slow, steady current binding sky to soil, storm to silence, and you to everything. The storm is beginning to fade, but your mind lingers on the people who don't let it pass. They chase it. While most of us retreat indoors, there are those who drive toward the lightning cameras and radar antennas strapped to their vehicles, hearts thrumming with anticipation. Storm chasers, sky hunters, part scientist, part daredevil, part philosopher of chaos. You can picture them now, a convoy of dusty pickup trucks rolling through the flatlands, headlights slicing through sheets of rain. The air smells like wet wheat and ozone. The radio hums with static as they listen to weather reports, searching for the telltale rotation on radar screens, the signature swirl that could become a tornado. They're drawn not by danger, but by beauty, by the pure physics unfolding in front of them. The storm has personality to them. They talk about angry skies and tired ones, about clouds breathing and deciding. To chase storms is to treat them as living beings, unpredictable but intimate. They speak in miles per hour and dew points, but what they really measure is awe. Many chasers are scientists collecting data for research, deploying sensors to understand wind speed, air pressure, and charge distribution. The information they gather has saved countless lives through better forecasting. But others chase art. They film lightning that crawls across entire horizons, capture time lapses of rotating supercells glowing purple in twilight. Some even record infrasound, the low, inaudible rumble of distant thunder that travels through the ground. If lightning is the sky's handwriting, storm chasers are its archivists. Of course, chasing isn't without cost. Every year, a few lose their lives to the very forces they revere. Roads turn to rivers. Hail shatters windshields. Winds strong enough to flip trucks sweep across open plains. Yet they return again and again, drawn by that rare moment when they stand before a massive rotating storm, the kind so large it fills the entire horizon and feels small in the best possible way. You imagine sitting beside one of them, parked at the edge of a field as the thunder rumbles overhead. The rain has stopped for now, leaving only the sound of wind scraping across the tall grass. The storm glows in the distance, pulsing like a heartbeat. See that? The chaser might say, pointing toward a dark curtain of rain illuminated by flashes. That's where the downdraft's collapsing. When that hits the surface, it'll kick up a new cell. Their tone isn't fearful. It's reverent, like they're describing the birth of a galaxy. Scientists still debate why people are drawn to storms. Some think it's an adrenaline addiction. Others call it a form of sublime attraction, that strange human craving for beauty mixed with fear. Psychologists have even coined a term for it, the call of the void. It's the paradoxical urge to get closer to danger, not out of recklessness, but out of longing for perspective. You don't have to be a chaser to understand it. Every time you stand by the window, during a thunderstorm, refusing to move, until that next flash, you're answering the same call. You're watching the unfiltered power of the natural world and remembering your scale within it. There's humor among storm chasers, too. They joke about the curse of the donut, where the moment someone buys food, the storm suddenly intensifies and they have to abandon it. They trade stories about near misses, about lightning striking so close it fried the car's radio but spared the occupants. They even have weather tattoos, lightning bolts, Anvil clouds, radar loops inked on their skin like badges of honor. Still, for all their courage, chasers know humility. They'll tell you about times they misjudged a storm's speed, about the eerie silence before a tornado touches down, or the moments when the wind carries the sound of debris snapping in the distance. They've seen destruction up close, homes reduced to splinters, fields stripped bare, and they know that the beauty of storms always comes with a price. One chaser once said, "A storm is honest. It doesn't hide what it is. It gives you everything: light, sound, fear, grace, and then it's gone." That honesty, you realize, is what makes storms irresistible. They have no agenda, no malice, just motion and consequence. You think about the footage those chasers bring back. The cinematic time-lapses of lightning stitching the horizon, the rotating cloud bases glowing green in sunset light, the sudden funnel forming and fading like a ghost. When you see those videos online, you're watching not just weather, but devotion. People giving chase to wonder itself. And maybe in their way, storm chasers are helping us remember something we've forgotten: that fear and fascination can coexist. That to respect nature is not to avoid it, but to understand it, to listen. They drive into the heart of chaos so the rest of us can sit safely warm and dry, marveling at the footage from our screens. Outside, the storm has quieted now, the lightning flickering only at the edges of clouds. You can almost hear the faint echo of tires splashing through puddles as those trucks move on to the next target, engines fading into distance. The hunters will keep driving until the horizon clears. The sky will rebuild, reshuffle, renew, and somewhere far away, another cloud will rise waiting for them. You smile softly. It's comforting to know that even when the storm ends here, someone is still chasing it, not to tame it, but to meet it one more time. The storm fades into silence, but not every storm ends on Earth. Out beyond the clouds in the vast cold darkness, other worlds flash and rumble in their own alien skies. You've seen lightning here, white, sharp, and fleeting. But imagine lightning the size of continents streaking through storms that could swallow our planet whole. Take Jupiter, for instance. The gas giant's upper atmosphere is a constant theater of electricity. NASA's Juno spacecraft has captured images of flashes so immense they'd light up the entire Earth's night side if seen from space. But Jupiter's lightning isn't white. It's pink or purple, glowing through clouds of ammonia and water vapor. The bolts leap through layers thousands of times thicker than any thundercloud on Earth. Some strike upward into hydrogen-rich haze, others deep downward where pressure would crush a submarine flat. Jupiter's storms have names: the Great Red Spot Oval BA, and dozens of smaller tempests, each spinning for centuries. It's strange to think that the same physics governing the thunderstorm over your roof tonight also powers those alien cyclones. The ingredients differ, but the dance of heat, moisture, and motion remains the same. Saturn, too, has its tempests. In 2011, Cassini recorded a megastorm so vast it wrapped around the entire planet, lasting for months. The lightning bursts were up to 10,000 times brighter than anything on Earth. Astronomers call them Saturnian flashes. The storm generated radio emissions so strong they could be heard as static through Cassini's instruments, a literal cosmic thunder soundtrack. Scientists still argue whether those massive lightning bolts form the same way ours do. On Earth, it's ice collisions that separate charges. But on Saturn or Jupiter, where temperatures and compositions are exotic, no one's certain what drives the spark. Some theories suggest ammonia crystals. Others say metallic hydrogen. Whatever the cause, the outcome is the same: a flash of light, a roar of energy, a planet exhaling in electricity. And then there's Venus, wrapped in its perpetual shroud of sulfuric acid clouds. For decades, spacecraft have detected mysterious radio pulses that hint at lightning, though no camera has ever captured a definitive flash. If Venus does produce lightning, it happens in a world where temperatures melt lead and pressures crush steel. Imagine thunder rolling through that golden haze, slow, muffled, echoing through dense acid fog. A storm you could never see but always feel. Earth isn't the only rocky planet with a sky that rages. Mars, though thin-aired and dusty, occasionally brews static electricity during dust storms. Tiny particles rubbing together generate charge-sparking discharges invisible to the eye, but real enough to affect robotic explorers. The Perseverance rover carries instruments that listen for these faint electric pops. They may be whispers compared to our booming thunderstorms, but they still carry the same electric signature, a reminder that even a dead planet hums with energy. One of the most beautiful extraterrestrial storms happens on Saturn's moon Titan. There, methane rains from orange skies, forming rivers and lakes, not of water, but liquid hydrocarbons. Titan storms roll across frozen plains, flashes reflecting on oily seas. Each drop falls in slow motion, the thick atmosphere cushioning its descent like a feather through honey. The sound of thunder there, if you could hear it, would be a deep, muffled rumble stretching for minutes instead of seconds. And beyond Titan, even more exotic weather exists. On Neptune and Uranus, lightning flickers inside storms where winds reach 1,500 miles per hour. Their thunderclouds aren't made of water, but of methane and hydrogen. The lightning could be as bright as Earth's sunlit sky, if only for an instant. Farther still, in the imaginations of astrophysicists, there are brown dwarfs, failed stars that glow faintly in infrared light. Observations suggest some of them host storms of molten iron with lightning powerful enough to vaporize metal. Imagine rain not of water, but of liquid glass and lightning bolts that tear through a sky of fire and vapor. The universe, it seems, has never met a form of chaos it didn't enjoy. You laugh softly at the thought that lightning may be the most universal language in the cosmos. Across planets and moons, it's always the same message: friction, imbalance, release. Whether it's ammonia on Jupiter or methane on Neptune, the laws of electricity don't care where they play. The dance of positive and negative updraft and downdraft, spark and sound, it's everywhere. There's a peculiar comfort in that. No matter how alien a world might seem, lightning connects us. The same spark that once danced through Earth's primordial sky could be flashing right now on a planet you'll never see. Somewhere, billions of miles away, a storm is unfolding, massive, silent, unseen. The clouds swirl, the charge builds, and a spark leaps across the void. It lasts less than a second, but travels thousands of miles. No thunder follows, not in the vacuum between worlds, but the energy ripples through space, caught by distant instruments. You take a breath imagining it, the soundless lightning of other worlds, the infinite repetition of nature's oldest rhythm. Every flash, a reminder that the universe is alive with storms, and we sitting beneath our fragile clouds are just one small flicker in that endless electrical sea. The night outside your window feels calm now, but the cosmos is still rumbling. Somewhere far above, storms are raging in colors we can't see and atmospheres we can't breathe. The universe hums alive with thunder. You pull the blanket closer, but your mind's still wide awake, because long before lightning detectors and weather satellites, humans had only their eyes, ears, and imagination to explain the sky's fury. Every culture found its own answer to thunder's voice. Every civilization gave the storm a soul. For the ancient Greeks, thunder was Zeus speaking, his bolts hurled in judgment, his rumbling laughter echoing through the mountains. The Norse imagined Thor hammer in hand, riding a chariot, pulled by goats that sparked lightning with every wheel turn. Far across the world, the Yoruba people of West Africa feared and revered Shango, the god who threw stones of fire and punished liars with lightning strikes. It didn't matter the continent or century, everywhere, people saw storms as messages. In Japan, farmers once bowed to Raijin, the thunder spirit, so he'd bless their crops instead of destroying them. Among the plains tribes of North America, the thunderbird ruled the western sky, its wings flapping to create thunder, its eyes flashing lightning. You can almost imagine them watching a storm roll over open prairie, feeling both terror and gratitude. Thunderstorms inspired prayers, dances, and rituals long before science gave us volts and currents. Lightning was divine punctuation proof that the heavens were alive and paying attention. Even today, that awe lingers. You can explain the charge separation, the temperature spikes the shock waves, but deep down, you still feel that primitive awe when the sky cracks open. Some part of your brain whispers, something bigger than me is awake. It's fascinating how those old stories often contain kernels of truth hidden beneath poetry. The Vikings imagined Thor's hammer, striking an anvil in the sky, unknowingly describing the same physics that forges fulgurites in the ground. The Aztecs believed their rain god Tlaloc used lightning to fertilize the earth. And in a sense, they were right. Lightning creates nitrates that nourish soil. Myth became metaphor, and metaphor quietly matched science. Scientists still argue whether myth-making was just a survival reflex or something deeper, our first attempt to translate the untranslatable. Maybe it's both. When you live in a world where a single bolt can set forests ablaze, you learn to tell stories that make chaos feel personal. There's also comfort in knowing storms weren't always seen as punishment. Many ancient societies treated them as renewal, a cleansing of old energy. In Hindu mythology, Indra's storms restored cosmic balance. In Pacific Islands, thunder was said to wake sleeping seeds underground. The idea that destruction could also bring fertility runs through human history like an electric thread. And you can't help but smile at how universal storm fear once was. Even kings trembled during lightning. Medieval monks recorded heavenly fires in manuscripts convinced they marked divine displeasure. Villagers rang church bells during tempests, believing the sound could chase thunder away. Ironically, more bell ringers died from lightning strikes than storms ever destroyed steeples. It's as if the sky couldn't resist proving a point. There's humor too in how humanity adapts. Benjamin Franklin's famous kite experiment was part science, part heresy in its time. A man literally tempting the gods with string and metal. Yet from that defiance came understanding, from understanding came protection, and from protection came peace. Today you don't fear lightning as divine wrath, but maybe you should respect it the same way the ancients did. Every flash you see is older than myth itself, a spark of pure physics that once inspired gods and legends. And yet, myths still evolve. In modern times, the storm remains a storyteller's muse. Movies use lightning to signal revelation or transformation. Poets compare heartbreak to thunder. Filmmakers time emotional climaxes to the crack of a storm. The same drama that terrified cave dwellers now scores our fiction. The setting changes, but the emotion stays. Maybe that's the real meaning of all those myths, not explanations, but invitations to feel. The storm doesn't just frighten, it humbles and connects. It's one of the few forces that still reminds humans they're not in charge. So as thunder grumbles again somewhere in the distance, think of it not as noise, but as an ancient language once spoken by gods, retold by poets, and translated imperfectly by science. You let your eyes close for a moment. The stories fade, replaced by the steady hum of the present storm. You smile, realizing that for all our progress, we're still the same creatures looking up, whispering into the dark sky. Tell me what you mean. The world outside has gone quiet again. But the modern storm, the one humanity built, never sleeps. Radar dishes spin through rain. Satellites glide above clouds, mapping lightning in real time. Supercomputers churn through trillions of data points to predict where the next cell will form. The sky still rages, but now we listen with machines. You can almost picture it, the control room of a weather center at midnight. Screens glow blue and green. Meteorologists sip lukewarm coffee, watching storms swirl on their monitors like living art. A red blotch stretches across a state line, pulsing brighter with each lightning flash. Someone leans forward, murmuring, "That's rotation forming." And an alert goes out before anyone outside even knows a storm exists. For thousands of years, humans could only wait for thunder to arrive. Now we chase its birth. Radar sees through clouds. Doppler systems measure wind shear, the subtle twist that warns of tornadoes. Even the lightning itself is tracked from orbit, captured by sensors aboard satellites like GOES-16, which can detect 500 flashes per second across the hemisphere. What once terrified us now blinks on a dashboard. But even with all this technology, we're still guessing. The atmosphere is a puzzle too vast to solve completely. A few degrees difference, a few seconds delay, and a forecast shifts from drizzle to disaster. Scientists still argue whether AI can truly predict storms or if it merely recognizes patterns after the fact. Weather remains a humbling reminder that not everything can be simulated. Yet the progress is staggering. In 1950, meteorologists could give only a few minutes warning before a tornado. Today, many areas get 15 or 20. Hurricanes that once struck without notice are now tracked across oceans for weeks. The same thunderheads that inspired fear in ancient temples are now dissected by algorithms, pixel by pixel, voltage by voltage. Technology hasn't killed wonder. It's just reframed it. We marvel at the data now, at how something as chaotic as lightning obeys equations so delicate that the wrong number in a model can ripple into an entire continent's forecast. The more we know, the more mysterious the system seems. Still, there's a dark side to prediction. Every radar image is also a warning of vulnerability. We build taller towers, but the wind grows stronger. We pave more cities, and the heat fuels new storms. Human progress has changed the weather itself. Urban sprawl creates heat islands, concentrating warmth that breeds thunderstorms. Jet engines seed contrails that alter cloud formation. Factories fill the air with aerosols that either feed or suppress rain, depending on their chemistry. It's unsettling to realize that we're not just studying storms, we're helping make them. In some regions, weather modification experiments have already blurred the line between science and ambition. Governments have tried to seed clouds with silver iodide to coax rain or weaken hurricanes. The results remain debatable. Scientists can't agree whether these efforts truly work or merely interfere. Still, the desire persists. If we can't escape nature, maybe we can negotiate with it. You smirk at the irony. For all our power, we still resort to pleading with the sky, only now through data and funding proposals instead of prayers. The tools have changed. The instinct hasn't. Even the instruments we send upward aren't immune to the storm's humor. Weather balloons launched daily across the planet sometimes rise straight into thunderheads. They record everything: the pressure drop, the moisture spike, the violent turbulence, until lightning vaporizes their sensors in midair. A brief spark on a radar screen, a tiny echo of nature saying, "Nice try." But amid the seriousness, there's hope too. We've learned how to make buildings safer, aircraft smarter, and power grids more resilient. Pilots avoid storm cells using radar that paints turbulence in color. Engineers design skyscrapers that absorb strikes and ground them harmlessly. Even our phones now buzz with alerts that give us minutes, sometimes hours, to find shelter. And yet, despite every advance, we still pause at the window when lightning flashes. We still hold our breath when thunder rolls too close. Technology hasn't erased our instinct to marvel. It's just made us better informed about what we're marveling at. Scientists joke that we've gone from fearing storms to falling in love with their math. But maybe that's the natural evolution of awe. Fear turns into curiosity. Curiosity turns into understanding. Understanding circles back to respect. So as you sit here listening to distant rumbles monitored by satellites, you can't help but feel a quiet gratitude for every radar pulse, every data stream, every human being somewhere out there, watching the same sky, trying to make sense of it. The storm outside fades completely now, but on screens around the world, other storms are blooming. The machines keep their vigil. Humanity keeps learning. The sky, patient and unpredictable, keeps teaching. And though we've mapped its patterns, the truth remains. You can predict a storm, but you can't own it. You can only listen. The storm is almost gone now. The thunder that once cracked across the horizon has softened into a distant heartbeat, fading like an echo from a dream. The air smells fresh, cool, and heavy with the perfume of wet earth. Somewhere, water drips from the edge of a gutter in slow, steady rhythm. The chaos has passed. What's left is calm, the kind that feels earned. You open your window a little. The cool night air slides in, carrying that unmistakable scent of after. There's a hush, a wide, clean silence that settles over everything. The storm has scrubbed the world. Trees glisten under streetlights, their leaves trembling with leftover raindrops. Puddles shimmer like molten silver across the pavement. Even the insects hesitate to start their songs again. Meteorologists call this phase the dissipating stage, the moment when downdrafts overpower updrafts, cutting off the storm's energy supply. In human terms, it's the sky saying, "Enough for now." The remaining rain falls gently, more like a whisper than a roar. The thunder, once fierce, mutters softly, as if ashamed of its earlier tantrum. Scientists still debate exactly how a thunderstorm decides to die. Some say it's temperature balance, others point to shifts in humidity or the intrusion of dry air. But maybe the truth is simpler. Every living thing, even a storm, eventually tires. The energy disperses. The rhythm slows. What was once fury becomes memory. You watch a drop of rain. cling to the edge of the window pane. For a long second, it resists gravity, trembling, then finally lets go. It slides down, joining a tiny river flowing toward the sill. That's how storms end, not with explosions, but with surrender. The quiet that follows a thunderstorm has its own weight. Psychologists have studied why people feel calmer after heavy rain and found that negative ions in the air can genuinely soothe stress. Your breathing slows, your muscles loosen. The body seems to recognize safety before the mind does. You can almost hear your heart sinking with a soft patter outside, a slow tempo of peace. Even the landscape changes. Dust is gone. The air feels heavier but cleaner. In forests, leaves glisten like polished emeralds. Streams swell and carry nutrients downstream, feeding roots and soil. In cities, the asphalt shines, reflecting neon signs like rivers of color. The planet drinks, exhales, and resets. If you could look from space right now, you'd see faint tendrils of steam rising from where the rain has cooled hot ground, breath from the earth itself. The storm that once looked monstrous on radar now dissolves into wisps, its towering clouds collapsing into ribbons of mist. What's left is balance restored. And yet inside that peace, life stirs. Frogs begin to croak again in nearby ditches. Birds flutter cautiously from their shelters, testing wings still damp from the downpour. Even worms emerge from the soil, drawn by the softened earth. A thunderstorm doesn't just end, it gives birth. The air may be still, but the world beneath it bursts quietly back into motion. It's easy to forget how vital these tempests are. Without them, forests would dry, rivers would thin, and the electrical balance of the planet would falter. Every storm is both a cleansing and a contribution. The same rain that floods valleys today will nourish roots tomorrow. The same lightning that frightened you hours ago has charged the soil with new compounds, fertilizing the fields it passed over. Destruction once again gives way to renewal. You can hear the last raindrops falling from the roof one by one, the sound fading into memory. There's something deeply human in the urge to sit and listen until it's all over. Maybe it's the same instinct that made our ancestors watch storms by firelight, waiting for the sky to calm before stepping outside again. That moment when fear turns to wonder. That's what stays with us. You think about the thousands of storms happening somewhere else right now, each following the same cycle: birth, rage release, silence. Somewhere, another person might be sitting by their window, too listening, breathing, feeling that same quiet awe. The air tastes metallic, but pure. You take another breath and exhale slowly. The lights from distant houses reflect off the damp road, turning the world into a watercolor. There's no more thunder, only the low sigh of the wind brushing past your eaves. You've reached the calm after chaos. The world feels different, washed, renewed, and momentarily still. You know the storms will return as they always do. But for now, the silence feels sacred. You close your eyes, and the sound of water dripping fades into rhythm with your heartbeat. Nature, it seems, has found its tempo again. The storm is gone now. What's left behind feels like a dream dissolving into morning. The air is cool and soft, the last drops of rain ticking gently from branches like punctuation marks at the end of a long sentence. Everything glows faintly. Streets, rooftops, leaves, all reflecting the shy silver light that follows the storm. The sky has returned to its ordinary gray, yet somehow it doesn't look ordinary at all. It looks peaceful, as though it remembers what it just was. You sit still for a while, listening to nothing. No thunder, no wind, no rush of water. Just quiet. Vast and deliberate. Silence, you realize, isn't the absence of sound. It's the presence of rest. The storm has left the world cleaner, lighter, maybe even gentler. You can feel it in your chest, that unclenching sensation that follows release. If you've ever wondered why rain makes people sleepy, scientists think it's because of the steady, low-frequency sound waves. The kind that lull your nervous system into calm. Thunder wakes you, but the aftermath rocks you back to rest. Even the scent of wet soil petrichor triggers relaxation in the brain. Nature, it turns out, knows exactly how to ease you down from adrenaline. And as you breathe in the damp air, you can almost sense the storm's ghost still lingering above. The leftover charge, the faint hum of the global circuit still balancing itself out. But it's gentler now, barely noticeable. You could almost mistake it for the sound of your own pulse. Somewhere far away, another storm is already beginning. New clouds building, new energy rising. The world never truly stops moving. It only trades fury for stillness over and over again. That rhythm, you realize, is life itself. You glance outside one more time. The puddles have stopped rippling. A single drop falls from a leaf, sending tiny circles across the surface before fading. The reflection is perfect for a moment. Sky mirrored in water, peace mirrored in you. You think about all the stories the storm told tonight, about lightning veins and thunder voices, sky towers and cosmic tempests, gods and satellites. Each one was just another way of describing energy and motion. And now that motion has paused. Everything that needed to be said has been said. The quiet feels earned. You can feel the weight leaving your body the same way the storm leaves the sky. Slow, natural, inevitable. Your breathing falls into rhythm with the night itself. You could call this the calm after chaos, but it's more than that. It's renewal. The atmosphere resets, the pressure evens out, the trees drink deeply. And you, small, still breathing, are part of that same restoration. There's something almost holy in how the earth forgives itself so quickly. It rages, it shouts, it shakes its fists with lightning. And then moments later, it rests. No grudge, no bitterness. Just balance returning. If only people were so good at letting go. The stars peek through now. Faint, curious blinking between patches of thinning cloud. The fan hums softly in your room, blending with the last drips outside. The night feels slower, thicker, and kind. You realize you've been breathing to the same rhythm for hours, unknowingly synchronized with the pulse of weather and wind. You let yourself sink deeper into that quiet, where thoughts drift like leftover clouds. Still there, but harmless. Your muscles relax. Your eyes feel heavy. The mind, after all, follows the weather of the body. And so as the world settles into its hush, you let the storm's last echoes lull you to sleep. You've traveled through thunder and lightning, through the science and soul of the sky. And now you've reached its softest edge, the quiet where everything ends and begins again. Outside, a cool breeze slips through the window. The night sighs, the earth breathes, and you, wrapped in the calm it left behind, drift gently into that same silence. Sleep well, traveler of storms. The sky is calm now. The lightning has gone home. The thunder's voice has faded into memory. All that remains is the rhythm of rain in your dreams and the hum of a world at peace. By morning, the memory of the storm lingers, not in thunder or rain, but in the way light falls differently on everything. The world feels rinsed, polished, and reintroduced. Dew clings to grass blades, magnifying sunlight into tiny prisms. Birds, silent through the chaos, start their cautious symphony again, as if testing whether the sky is truly safe. There's something profound about how quickly nature rebounds. The same branches that bowed under the wind now sway freely. Streams, swollen by the night's downpour, gurgle with renewed clarity. Even the air feels recharged. Ions still dancing invisibly, carrying that bright metallic edge of ozone that seems to wake every sense. You breathe it in and feel your lungs stretch wider, as though they too needed cleansing. Scientists sometimes call this post-storm freshness atmospheric renewal. After heavy rain pollutants are scrubbed from the air, pollen is washed to the ground and dust settles. It's not just poetic, it's measurable. Airborne particle counts can drop by 60% after a good storm. The sky isn't just beautiful, it's doing maintenance. There's also something spiritual in the aftermath. Many cultures once believed dawn after a storm was sacred, a sign of forgiveness. In the Andes, farmers would walk the fields barefoot at sunrise, letting the wet soil squish between their toes, believing it grounded them to the earth's new energy. Maybe they weren't wrong. You can feel that connection even now. The puddles shimmer with early light clouds, scatter like retreating ghosts, and the breeze hums softly through the trees. Nature seems to whisper, "We've reset." Still, traces of the storm remain subtle but persistent. The leaves shine darker from their soaking, the air hums with quiet static, and somewhere in the distance, a far-off rumble reminds you that the system hasn't vanished, it's just moved on. The cycle continues elsewhere, unseen but alive. You realize then that a thunderstorm never truly ends. Its water flows into rivers, its heat feeds the atmosphere, its charge powers the global circuit. Even now, the molecules from last night's rain are evaporating into invisible mist, beginning their journey upward again. What feels like an ending is really just a transfer of energy, a continuation written in slower motion. The beauty of it all isn't in the noise of the storm, but in its quiet aftermath. The living proof that chaos leads to clarity. You step outside barefoot, feeling the cool dampness under your feet, and for a moment, the entire world feels freshly made. That night, long after the sky has cleared, lightning still flickers in your thoughts. Maybe it's because thunderstorms don't just reshape the air, they reshape you too. You carry a kind of quiet electricity afterward, a heightened awareness of rhythm and pulse. The storm leaves you charged even as it rests. Humans have always felt that pull toward weather, but scientists are beginning to understand why. Our brains are tuned to atmospheric change. When barometric pressure drops before a storm, our bodies actually respond. Heart rate rises slightly, serotonin dips, and senses sharpen. It's evolution's way of keeping us alert to danger. But when the pressure climbs again, after the storm calm floods back in like nature flipping a switch from fight to peace, it's a strange thought that every thunderstorm might be a shared biological event, syncing the heartbeat of every living thing in its path. Animals know it too. Birds find thermals from fading storms. Frogs call louder after the rain to claim territory. Even plants adjust opening stomata, wider to drink in the replenished air. There's also the emotional side. Some psychologists believe our fascination with storms comes from catharsis, the idea that we project our own tension onto the weather. The thunder releases what we cannot. The lightning flashes through our buried worries. And when the rain falls, it feels as though the world is weeping on our behalf, washing something clean that words never could. You chuckle at the thought maybe storms are the universe's therapy sessions scheduled by the clouds. But there's more. A scientific poetry in how storms connect to time itself. The water that just soaked your street has existed for billions of years, cycling endlessly through evaporation, condensation, rain, and return. That same droplet might once have fallen on a dinosaur's back, or frozen in a glacier, or drifted as fog above an ancient sea. Every thunderstorm is part of that immortal rhythm, the earth breathing in vapor and exhaling rain. And you, tiny and temporary, get to witness it. That's the gift. You look up once more at the night sky. The stars are back, faint but steady. The storm has moved on, its energy dispersed into the grand machinery of weather and water. Somewhere beyond the horizon, another cloud is forming, gathering moisture, heat, and charge, preparing to repeat the performance. The planet never stops rehearsing the same symphony over and over for as long as it spins. You smile, letting that realization settle. Maybe that's why people find peace in storms. Not because of their power, but because they remind us of continuity. We too are cycles, bursts of energy, moments of calm, inevitable renewal. As you close your eyes, you feel the faintest tremor of wind through the open window, of the last leftover whisper of the atmosphere rearranging itself. Somewhere far away, lightning flashes silently over the ocean, connecting heaven and water one more time. You drift toward sleep, knowing that when you wake, the air will be bright again, charged, clean, and alive. You wake before the sun, long before the city remembers to make noise again. There's a stillness so complete that even your breathing feels like a small intrusion. The storm that ruled the night has gone, but its presence lingers in the hush it left behind. You can taste it in the air, clean, heavy, almost sweet, like the first sip of water after thirst. Outside your window, the world seems washed into clarity. The puddles that once thrashed under rain now mirror the faint light of dawn, turning sidewalks into strips of pale silver. The grass bows low, jeweled with dew, each blade catching a spark of the coming morning. You can smell petrichor, that earthy perfume of life renewed, mingling with the last traces of ozone. For a long time, you don't move. You just listen. There are no engines, no thunder, not even the hum of insects yet. Just the soft, irregular patter of drops slipping from eaves and branches, the occasional sigh of wind weaving between trees. It's a silence so alive, it feels like sound in slow motion. The storm has done its work. What remains now is balance, the kind that exists only after release. The air feels denser, as if packed with invisible calm. The pressure that built in your chest through the night has vanished, replaced by the slow rhythm of the world exhaling. You've probably noticed how different the air feels after a storm, how every breath feels fuller, cooler, somehow more real. Scientists know why. When lightning cracks through the sky, it splits nitrogen and oxygen molecules apart, creating ozone and negative ions. Those ions bond with dust and pollution, clearing the atmosphere. It's as if the planet cleans its own lungs one storm at a time. You smile softly at that thought, that the same energy capable of destruction also purifies. That chaos, in its wild and ungoverned way, can leave things gentler than before. The sun begins to stir. A faint pale blush spreads along the horizon, illuminating the undersides of clouds that now drift like soft gray islands. Each one looks fragile, transparent, humbled, after the storm's fury. You notice how the light reflects off rooftops still glistening with rain. Every tile a mirror, every droplet a tiny prism. It's quiet spectacle easy to miss if you're not awake for it. You imagine the storm now as a traveler that has moved on, rumbling away over distant hills, taking its noise and fury to another horizon. Somewhere, people are waking to the same rolling thunder you fell asleep to. The world's tempests are always on rotation, circling the globe in endless exchange. At any given moment, nearly 2,000 storms are alive somewhere, each one breathing, rising, raining, and fading. That thought comforts you. There's symmetry in it. Chaos shared equally across time zones, across hemispheres. No storm is permanent, but there is always one somewhere making sure the cycle of motion continues. You pull a blanket tighter around yourself and watch the light grow. It's not the violent illumination of lightning, but something subtler, the soft gold of renewal. Every minute it stretches further, touching treetops first, then rooftops, then the small puddles in the street. Steam begins to rise where the first warmth hits water, curling upward in graceful wisps. The air hums with the faintest energy, not electric, but alive. If you step outside, you'd notice how the world feels cooler yet softer underfoot. The soil gives slightly still saturated from the rain. The leaves drip quietly onto one another, passing along what they've gathered like secret messages. Birds begin to reappear, hesitant at first, then bold. Their songs are different now, slower, richer, as if tuned by humidity. Even the wind carries a new accent, its rush replaced by a long exhale. You walk slowly, letting your shoes darken with dew. The air brushes your skin in a way that feels deliberate, like the world reminding you it's still here. Every sense seems sharper, colors deeper, sounds clearer, smells stronger. Scientists might explain it as higher humidity amplifying sensory perception, but it feels simpler than that. The world is whispering, "Thank you for waiting." You pause near a puddle, watching the reflection of the sky tremble with each new drop that falls from a branch. You remember how violent that same water was hours ago, crashing, pelting, slamming the earth. Now it's gentle, shimmering, harmless. It's astonishing how quickly nature moves from rage to grace, from chaos to calm, without apology. Maybe that's what makes it so beautiful. It doesn't linger on what it destroyed. It just begins again. You think about how storms in their wildness resemble emotions. They build quietly, pressure growing where it can't be seen. They flash, they break, they empty everything out. And when they're done, what's left isn't wreckage. It's space, clarity, the air between thoughts. Perhaps that's why people find peace after storms. The sky has done what we can't always do, release. The street light beside you flickers off as morning brightens. A soft blue begins to replace the gray. The clouds stretch wider, thinning like mist over water. Somewhere in the distance, a car engine turns over, tentative and small. The world is waking cautiously, not wanting to break the spell too soon. You imagine all the energy that raged above you last night, the lightning, the wind, the electric veins of the atmosphere, now dissipated, transformed into quiet molecules that will feed the next cycle of rain. The universe wastes nothing. Even the heat of lightning helps seed chemical reactions that sustain life. The same flash that terrified you could be nourishing the grass beneath your feet. A gentle breeze moves through, carrying the scent of wet stone and leaves. It's cool but soft, brushing against your face like a sigh. The world doesn't need to announce that it's healed. You can feel it. And maybe that's the quiet miracle of a thunderstorm. Not the noise it makes, but the silence it leaves behind. The calm after chaos isn't absence. It's renewal disguised as stillness. Everything in the world has been reset. The pressure, the temperature, the balance, and you standing in the middle of it are part of that calibration. You take another deep breath. The air tastes different now, clean, mineral, alive. For a moment you wonder how long the calm will last before the next storm finds its way here again. Maybe hours, maybe days. But that doesn't matter. The beauty of storms isn't in their permanence, but in their rhythm. They remind you that nothing, no feeling, no fear, no fury, stays forever. You glance upward. The sun finally breaches the horizon, scattering gold through the thinning mist. The first true warmth of day touches your skin, and you realize how easy it is to forget what sunlight feels like until it returns. The light filtered through wet air gleams softer, thicker, as if it knows the sky has earned its rest. You smile. The storm's story has ended, but yours continues. The world hums quietly again, and in that hum, you hear both memory and promise. The reminder that even in the aftermath, something new is always waiting to grow. So you stand there still as the morning breathing in the scent of renewal. You let your eyes close for just a moment longer. Somewhere in the distance, water drips one last time from a leaf. The sound is small, but it feels infinite. You've seen the storm's beginning, its fury, its silence, and its rebirth. And now you understand. It was never just weather. It was the world reminding you that calm is not the absence of motion. It's what happens when everything finally moves in harmony. You take another slow breath, eyes half closed, heart steady. The earth has exhaled, and so have you. And now the storm has become only a memory, a soft echo folded into the night. The air no longer trembles, it sighs. The clouds have thinned into faint ribbons, drifting across a sky that seems to move more slowly than before. You can almost feel the planet exhaling its great lungs, releasing the last of their thunder. The trees outside are still beaded with rain, glimmering faintly in the lamplight. Each drop reflects a quiet world, one small universe dissolving into another. The ground smells of renewal, damp earth, and living roots, the scent that always follows cleansing. The sound of water has softened to the smallest trickle, a thread of rhythm barely strong enough to hold you awake. You feel the pressure lift from your body, the same shift that happens in the air after a storm. The tension that built with every rumble now drains from your shoulders. The pulse that once raced with the lightning slows to something steady, like the tide easing back into its shore. Everything, it seems, has found its balance again. Somewhere in that hush, the world begins to reset. The sky cools, the soil drinks deeply, and the atmosphere folds into rest. You can almost hear it, that slow, invisible rearrangings of peace. Let yourself sink into it. Let the silence widen around you until it feels like an embrace. The danger is gone. The thunder has finished speaking. What remains is the softness that follows understanding. Close your eyes. The storm has taught you its lesson, that even the loudest chaos ends in calm, that even the fiercest light leaves room for rest. The world is quiet now, and it's safe to follow. Sleep well, traveler. The sky is clear, the air is kind, and the earth is breathing with you.